Okay, so let's find the centroid in the y direction. I think this would be a good one for differential area that's vertical. So we'll be dx thick and we'll be y tall. And then we just need to find the centroid of our shape. Now we're trying to find dy. So we just want to have, this will be the distance to that point. What would that distance be? It would just be our y height divided by 2. So our differential area, we're going to say is y dx, and we know that y is given by this, which is h over b squared x squared, and then dx. And h and b are constants, so we'll be able to pull those out. And then our centroid to our differential area in the y direction would be y over 2. And again, y is given as this, so we'll just say h over 2 b squared x squared. So there's all of our pieces. So start with the simpler of the two. We'll just integrate we know the area, it's just the integral of that. So in our case, our limits are in the x direction, so we're going to integrate from 0 to b dA, which is h over b squared x squared dx. I'm going to pull out my h and my b squared, and I'm left with just x squared, which is easy to integrate. That's just x cubed over 3, and we're going to evaluate that from 0 to b. 0 limits are always nice. Cuts your calculation in half. So when you put b in there, you get b cubed over 3. It looks like the b squared cancels, and you get bh over 3 for the area. I think that's reasonable. Now the numerator is the integral of the y to the centroid dA. When in this case is going to be, again we're integrating in the x direction, so it'll be 0 to b. So y bar was this thing, so I have h over 2b squared x squared. I'll just write it that way so you can see that that's one. And then dA, which is h over b squared x squared dx. We got lots of stuff we can pull out to make it a little cleaner. So I'm going to have h squared 2 b to the 4th, and I'm left with what? X to the 4th, which would be x to the 5th over 5, evaluated from 0 to b. So what's that turn out to be? Well, you put b in there, you get b to the 5th over 5. The b to the 4th cancels, so this looks like you get h squared b over 10. The 2 and the 5. That seem reasonable? So now my centroid in the y direction, by definition, is the last integral, bless you, divided by the area, which in our case would be h squared b over 10 divided by hb over 3. So the b's cancel, you get, what is that, 3h over 10? 0.3H? Is that reasonable? It seems reasonable unless I made a calculation error. You guys see any problems with that? That was a little easier than the last one. I thought it would be tougher with the symbols, but it actually worked out easier. Yeah, that looks good. So any questions about that one? Okay.